Good day everyone, I'm Marites Gazingan and I'm here to discuss about the blood vessels. So we just learned about the heart, which is the incredible organ that pumps blood all over our body to deliver oxygen to every last cell that needs it. But what does the blood move through in order to get around? So blood travels through blood vessels and there are a number of different types, so let's take a look at this. First, we need to be aware that blood vessels come in three varieties. These are arteries, veins, and capillaries. The first two, which are like the main highways, are easy to define. Arteries carry blood away from the heart and they are branched out as they go, becoming smaller and smaller. Veins carry blood into the heart, so they merge and become larger as they approach the heart. And then capillaries are the smaller vessels that make direct contact with the tissues around the body and supply them with oxygen. These are like the surface streets and alleyways. In terms of how oxygenated the blood is that travels through these vessels, it will differ depending on whether we are looking at the systemic circuit or pulmonary circuit. In the systemic circuit, the blood leaving the heart in the arteries is oxygenated and starting its journey around the body, while the blood returning to the heart in the veins is oxygen poor, having transferred about one-third of it to tissues during circulation. In the pulmonary circuit, it's the opposite. Blood leaving the heart in the arteries is oxygen poor, as it headed to the lungs to pick some up, while the blood returning to the heart in the veins is freshly oxygenated. Now that we have some terminology down, let's learn a bit about the structures of blood vessels. This will be quite similar regardless of the type of vessel, and must have three layers, which we call tunics, that surround the lumen, which is the hollow part that blood flows through. The first is the innermost tunica made of an endothelium that minimizes friction as blood travels, and must also have a subendothelial layer made of loose connective tissue. Next is the tunica media made of smooth muscle cells and elastic fibers. This muscle is regulated by the autonomic nervous system, which can initiate vasoconstriction where the muscle contracts and the vessel narrows, or vasodilation as the muscle relaxes and the vessels widen. This is important for regulating blood pressure and proper circulation. Lastly, there is the tunica externa made of collagen fibers for protection and structural reinforcement. Within this layer, if looking at larger arteries and veins, there is the vasa vasorum, a system of much tinier vessels that supply the outer layers of blood vessels with nourishment. Now, let's get more specific regarding the types of vessels. Arteries come in three groups. The first are elastic arteries. These are the largest and thickest, the ones near the heart. This contains more elastin than other vessels so that they can absorb more pressure, which is necessary as they have to withstand the pumping nearby. Next, there are muscular arteries. These deliver blood to specific organs and these are the most abundant. And lastly, we have arterioles. These are the smallest, the ones that lead into the capillary beds. Moving on to capillaries, these are the smallest blood vessels, as we said. These have just a thin tunica intima, sometimes just one cell thick, often adorned with pericytes, which are cells that stabilize the capillary wall. The lumen of a capillary is very small, just small enough for red blood cells to fit through in a single file. There are continuous capillaries which are found in the skin and muscles, and these are the most common. These are fenestrated capillaries which are covered with pores, allowing them to receive nutrients from digestive food and to allow hormones to enter. And then there are sinusoid capillaries. These are found only in the liver, bone marrow, spleen, and adrenal medulla. Capillaries are always found in capillary beds. These are network of vessels going from an arteriole to a venule. This typically consists of a vascular shunt, which is the central vessel comprised of the metarteriole on one end and a thoroughfare channel on the other. And then between 10 and 100 true capillaries connected to the vascular shunt by precapillary sphincters. When these are open, blood flows through the entire capillary bed, which is called microcirculation. And when closed, blood simply moves through the vascular shunt. This status will depend on what's going on the body at a given time. Through the capillary beds, we have moved from arteries to veins. So let's mention some things about this. When capillaries unite, they feed into a venule and venules join to form veins. These look very familiar to arteries except that their walls are thinner and the lumens are larger. And there is less smooth muscle in the tunica media, while the tunica externa is thick, full of collagen fibers and elastic networks. Veins experience much lower blood pressure than arteries, and in order to prevent backwards flow, there are a number of venous valves that help direct blood flow, especially the limbs where blood has to go against gravity to get back to the heart. With some of the finer details out of the way, we can safely zoom out and look at both systemic circuit and pulmonary circuit as a whole, and identify some of the key features of each. There are so many individual arteries and veins with specific names. Let's examine a few diagrams about them. First, looking at the pulmonary circuit, we see the oxygen-poor dark red blood gets pumped from the right ventricle into the pulmonary trunk, which becomes the pulmonary arteries. These quickly branch to form arterioles and then many pulmonary capillaries where oxygen is gathered from the air sacs in the lungs. As it becomes oxygenated, the blood turns bright red and these capillary beds drain into venules which join to form the two pulmonary veins that exit each lung. And these lead back to the left atrium of the heart to complete the circuit. From there, the systemic circuit begins as the oxygenated blood is pumped out of the left ventricle through the aorta. This splits into many smaller arteries, which is split into arterioles and then capillaries that run through all of our organs. These vessels all have names that reflect either their specific location, the organ served, or the bone they follow, and they are not always symmetrical. The head and neck have specific arteries, as do the upper limbs, the lower limbs, and the abdomen. Then, of course, the blood makes its way through to the veins, the largest of which are the superior vena cava and the inferior vena cava. These feed back into the heart, and of course, there are once again specific veins found in the head and neck, the upper limbs, the lower limbs, and the abdomen, all with names that correlate with location, organ, or bone. So that gives us a decent picture of all the blood vessels in our bodies and the journey that blood takes as it supplies all of our tissue with oxygen and other substances. And that ends my discussion. Hope you learned from it. Thank you for listening and God bless.